maybe not concerned, but just more need some knowledge about the drilling process and what that means. So I've put together a short presentation just to go over what I'm calling the life cycle of a well. So from the very beginning of the review process all the way down to when it's abandoned and the site is restored. So again, what I plan on doing here today is just giving a brief history of oil and gas in Michigan, what the role is of the Oil, Gas, and Minerals Division. That's what I'm part of. It's a division within EGLE. Talk about the typical life cycle of an oil or gas well, and to answer any of your questions. So, in 1925, an oil boom occurred in Saginaw, Michigan, and that made the state of Michigan develop its first environmental laws in 1927, which was set to regulate production of oil and gas. Since then, there have been over 61,000 permits issued to companies to do the drilling. On the side here on the map, it's kind of hard to see, but there's a bunch of little dots all the way throughout the state. Those are all the wells that have been completed. Since we've started collecting records since 1927. Right now, active wells throughout the state, there's 4,500 oil wells, 11,000 natural gas wells, over 3,000 gas storage wells, and 1,300 water injection and disposal wells. What's the role of the Oil, Gas, and Minerals Division? We are part of the Michigan Department of Environment, Great Lakes, and Energy, and our responsibility is to regulate all oil and gas activities. So that goes from the permitting, the drilling and completion of a well, production, plugging, and then site restoration. So first part was the permit. So once we receive a permit, we go through an extensive review of that. We look at the casing and the sealing program to make sure that all the casing is set in specific formations, preventing the fluid from moving where we don't want it to. Well control measures, the spacing of wells, environmental impact assessment, and that includes the drilling rights, the construction of the drill pad, the access road, flow lines, the land use, zoning, topography, if there's hydrogen sulfide in the oil, soil erosion and sedimentation control. We also do a features review, and that's any feature that is on the surface, including like buildings and different structures, if there's water wells nearby, any utilities, surface water, wetlands, if there's endangered species in the area, any historic areas that may be close by, and if there are any other oil and gas wells within a certain radius. We also look for city water wells or municipal water wells, also residential wells, just to see how close they are, and we have strict guidelines on how close, depending on the type of water well you have, how close the oil or gas well can actually be. We look at reserve pits. That's where fluids from the drilling operations are stored. Sometimes they can be drilled or stored in a lined pit on the surface. Other times they have to be stored in containers, depending on proximity to the groundwater or any other sensitive areas. And then we also send notification letters to landowners, county clerks, and to emergency managers. So that's, once we go through this entire process and make sure that the permit meets all the guidelines and the regulations, then we can issue a permit. So once that is issued, the construction of the drilling pad can start, and that is where they scrape off the top layer of topsoil, and they segregate that and store it and create a berm around the well. And then they also level out the ground so that they have a nice level drilling pad to work off of. Again, that topsoil is segregated and stored so that when the site is restored, that topsoil can be reused again. So once the land has been leveled, they bring in and install these impermeable liners, and that goes on portions of the drilling pad where the drill rig will be, and the storage tanks, any of the equipment, and that is a barrier to prevent, if any incidences do occur on the surface, from getting into the soil and the groundwater during the drilling operations. Once everything's set up, they bring in the rig. This is a picture of a rig once it's all set up. So we have the rig, we have circulation pits, mud control, a number of different pieces of equipment come on. Each piece is set on that liner to, again, prevent any interaction between the activities and the subsurface. So there's two typical kinds of drilling that typically do happen. One is just a vertical hole where you go straight down and you try to get to your target formation. Other times you're unable to do that based off of some of the surface features. You might have surface water, wetlands, a city, a few other things where drilling is not really appropriate or not allowed. In those kind of cases, they can find a piece of land that's nearby, and they can drill down horizontally for a bit, and then they can slowly, directionally change their drilling on an angle to still hit that formation that they want. This way it protects the surface, and they can still try to go for their target formation. Next, we're going to talk about the casing program. This is the steel pipe that's put in during drilling, as you can see in this picture. And they're cemented in place to prevent any of the fluids from any subsurface formations from moving throughout and getting to fresh water or any other formations that are not desirable. So first we start out with the conductor and surface casing. This is at the top. The first one is our conductor. It's the largest casing that will go in, and that's typically pounded or driven into the ground. Most of the time around 60 feet or so. This prevents shallow groundwater from entering the drilling process, and it prevents cave-in during drilling. Next, we do a smaller diameter surface casing, and that gets drilled down, and we have to go 100 feet past the base of the fresh water interface, and we also have to be 100 feet into bedrock. Once we get down to that, surface casing is put into place. It's a big steel pipe, and then it's cemented into place up to surface. That's left to sit and make undisturbed so that there's no movement throughout it while it cures. And once that is all set, they can continue drilling. And next, we go down to our intermediate casing. This is typically half to 2/3 of the total depth of the drilling process. And this is put in place, and it seals off formations that we may have encountered that could have fresh water, brine, or areas that would take the drilling fluids. And this separates that, and that is sealed in place again once you get down to that depth, and it's cemented into place with hundreds of feet of cement, up to thousands. And again, that's left undisturbed for a period of time to make sure that there's no movement in that. And then the final string is our production casing, and that's the casing that goes down to the formation that the company is targeting. So that will go down. That's your deepest string, and again, that is set in place again. It's cemented. It's steel pipe cemented into place. and that has to sit again undisturbed while the cement cures. So once you have that, if the company has decided to continue the process of installing an oil or gas well, they go through completion. And that's where you perforate the pipe, which is putting holes into the pipe where you have your formation rock. And a special tool is lowered into your casing, and it's shot out, and it goes through the steel casing, the cements, and into the formation. And this allows the fluids from that specific formation to enter the casing. And that's where the well would be produced from. After the well is perforated, it can go through a couple different options to enhance its flow. The first one is hydraulic fracturing. I'm sure you've all heard that in the news over the time, but it's a process where water is pumped down into the hole at high pressure, and that pressure would fracture the rock down way deep into the rock, and it again allows fluids to move. And then silica sand is also injected with that. It's called a proppant, and that keeps those cracks open after the pressure is released. That's typically not used down in this area. That's for different formations, for typically gas, and that's more of a northern Michigan activity. Down here we can have acid stimulation, and that's where typically it's hydrochloric acid is put into the borehole, and that will eat away carbonate rock. Hydrochloric acid dissolves the rock, and that allows proper flow. It'll go through the cement right at that formation where it's been perforated. It'll go through the formation rock, and then that allows the fluids from the formation to enter the production casing. So once they've done all that and they have a well that they want to produce, some equipment's brought in. So some of the typical equipment you might see is a pump jack up here. If you have a natural gas well, it's a different type of wellhead. And then if you are storing oil and it is producing, you can have a tank battery, and those are just storage tanks. And then if you have to treat or if you have to get gas out of the oil, separate the oil, you'll have other equipment that could be at your facility, which you can see down here. All of these pieces of equipment do have secondary containment, which is just a barrier again to prevent anything that is released up at the surface from getting down below. The wellhead, where you drill where the pump jack is or where the natural gas well is, those are in boxes with a liner around it. So if there is something that does happen at the well, it is contained, it can be cleaned up. We are made aware of what has happened, and we're there to make sure that it does get fixed. The storage tanks have to go through a design process and a review process just as a permit would, and those go into large burned areas with liners. So anything that is released on accident would be contained. Same with any facility equipment. They all go through a process, the similar thing as our permit for the well, and then each piece does have secondary containment. So once a well has been depleted or emptied, the company can decide to plug the well. And the plugging of the well is a process of going back into that well and putting mechanical plugs and cement, hundreds of feet thick, and they're called cement plugs at strategic areas that prevent any fluids from in that well from ever getting to the surface. They are designed and written by area geologists like me. They're approved by our supervisors, and they're issued to the companies. So the well would get abandoned. Part of that is 4 feet below grade. They cut off the well. There's cement plug right at the surface, and then they put a steel plate, they weld it on, and they put the permit number on the steel casing. In case it ever does get dug up, they can identify what the well is and who has the liability of the well. So then it goes through the process of restoring the site, where you take all that dirt and the soil that was burned up, any messes, the liners for any of the equipment is removed. The area geologist comes out and they verify that things have been cleaned up. Any contamination concerns are addressed and remediated at that time, and then approval is given to complete the restoration. And that is something that would be in the lease agreement on how that would be done. Typically, it's restored back to the condition it was when it was taken over. But other conditions can be put in the lease agreement. In summary, the state of Michigan has some of the most comprehensive and effective oil and gas regulations in the country. For oil and gas, for us, it's regulated through Part 615, Part 616, and 617 of Public Act 451. Each one of these is a comprehensive set of rules and regulations that we enforce. We go out regularly, inspect all these locations, and make sure that the operators are doing their job and that no contamination is going to be found, and if it is, it's taken care of very quickly. In the state of Michigan, currently, or in 2018, we had 59 full-time employees throughout the state. And the Oil, Gas, and Minerals Division has a skilled team of committed geologists and employees that enforce and regulate every county throughout Michigan. Every site is inspected regularly. We have set timelines when things do have to be inspected, and we have conducted in 2018, over 14,000 inspections were conducted throughout the state. In 2018, there were 75 permits that were issued. 6 of them were denied or are revoked. And then the protection of groundwater and surface water is our biggest and most important role. It's our highest concern, and this is accomplished through the inspections, our enforcement, our rules and regulations, our casing requirements, our construction, through our spill containment and secondary containment, through the PEAS, our pollution hotline, where if things do happen, we get calls any time of the day, and we'll come out and verify what's happening, or have someone come out and take care of any of the issues. Again, we've done thousands of inspections every year to make sure that what is going on is safe for everyone. And again, the groundwater, surface water is our highest concern.
I got a question.
Yes.
Okay, we have municipal wells
Yep.
here, and I assume you do your due diligence and make sure that they wouldn't be compromised before a permit's issued?
Yep, that's part of the review process.
Yeah, because that's very important to the city.
Yep, no, I understand that, and that is, it's just one part of our review process. We identify where the wells are, what that is, proximity to where they want to drill, and if that is going to cause an issue during the process. Yes.
I was just curious, earlier on in your presentation, in the list of the types of wells and the number of them, the bottom item was disposal wells. What are those for?
Yeah, so fluids that are produced during drilling or oil and gas activities typically are brine. So the water and the oil is separated, and that water that is produced has to be disposed of through certain wells. And that's a well that is drilled to a formation and is injected back into the ground. And it's water that was down in a formation is just being again, put back to a different formation to hold water.
Are those by each site, or is it,
No,
they
that's-
just truck it to the site that has it?
That's part of trucking. Some sites have their own, but typically it's, one operator would handle multiple, wells.
That's gonna have no effect on the Bell River at all?
It shouldn't, again, it goes through our process, review, so we look at the Bell River, check the proximity, but our casing program would prevent any of that fluid from, or the groundwater from them from entering that, so.
And are them people gonna come to anything on our land, or everything's underground?
I'm not sure where the well is proposed at this point. I have not received an application. But again, that would go through our review process, beforehand, so.
Jason, just, my name is Marty. A couple questions for you, if you would.
Yep.
Number one, hydraulic fracturing, as you certainly know, takes a tremendous amount of water.
Yes.
Millions and millions of gallons of water. Where's that water going to come from?
That comes from wells that are drilled specifically for that.
At the site.
Yes.
So we're going to take millions of gallons
No,
of
That's not
water.
gonna
No,
use
that's,
the water
again,
table?
that's typically something that's not done in this part of Michigan, and it's not expected for the fracture.
Absolutely not. There's no fracking done on these reservoirs here in St. Clair, Macomb.
What's the closest setup that has this type of setup around here? Which city has
Wait.
this?
Hydraulic fracturing?
No, has the, what you're gonna do out
I would think probably Riley.
Right,
Yeah, it's,
Columbus,
yeah, we're just, or Columbus.
the Wales.
So
Yeah,
hold-
there's one in Wales Township.
Hold on.
Yes.
What you just described was hydraulic fracturing now, right?
Yes,
But that's not what we're doing here.
it's not expected to be done here. It's not,
It's not expected or it's not going to be.
Can I
again, yes.
help address some of these?
Just to be clear, Jason is from the state, he's
No,
not
I
drilling?
understand,
Okay.
but I watched his presentation.
So there was two parts, you had the hydraulic fracturing, two methods, one was hydraulic fracturing,
Yeah.
one was the acid.
Acidizing.
Typically fracturing, hydraulic fracturing is done in a shale, which we call unconventional source rock. And the purpose of fracking is to interconnect. The shale is like a honeycomb, each individual cells, and they're not connected to each other. So when you go in and frack it, you kind of create little feces that connect all those cells together, and that's what gives you the ability to move oil and gas out of that particular reservoir. These reservoirs here, which have been in St. Clair since the late 50s, none of these have ever been hydraulic fracked. We go in and stimulate these with the hydrochloric acid that he talks about. And we treat the Niagarans with almost like kid gloves. You have to be very patient and just let the formation do what it wants to do. The acid is mainly to clean up the drilling debris and the cement around the initial wellbore and to etch the carbonate rocks, which will allow kind of a pooling area around that wellbore where your production casing is set. So there will not be any, again, hydraulic fracturing or any reason to take millions and millions of gallons of water from any of the aquifers in this area. Typically, to complete a well, you're looking at using no more than 100 barrels of either fresh water or brine water. So it's very, very minimal.
I have a question.
Yes.
What, I guess a lot of the concern I have would be, you're going through the aquifer.
Yeah.
Well, what is the failure rate on that? How many times has it, really, how often do they contaminate the aquifer? Because that's our water. I'm sure it does happen, or it doesn't, I mean, it's very rare, or what are the chances?
I've never seen it happen.
No,
We've never seen that happen.
We haven't had a report since the rules have been put in place, the more recent. They had it way back, like when they first started drilling in the 20s and 30s and things like that, but since we've, realized what our forefathers did, they came up with rules and regulations to, that's that surface casing they talk about that has to go through into competent bedrock and be cemented back to surface. So that's a whole protective layer in itself. Then you have 2 other strings of casing, cement, so yeah, it's not gonna be contaminated through the wellbore. It might be from a big spill at surface, let's say if a tanker blew up or something like that, but again, since like the 80s, they've now started making them put liners around all the tanks and things like that. So we have old historical problems that we're still dealing with from the 20s and 30s, but to today's standards, we haven't had a report on that.
So the casing pretty much works.
Yes.
It works very well. I've been in the business over 40 years, and I've never heard or seen one instance where a person's water source has been contaminated through drilling operations. You know, if you look in this general area here, again, you know, Niagara and Lease were first discovered over here in the late 50s. And even today, we're back in the casing programs back then were not nearly as, I'll say, stringent as they are today since the early 90s. There's no well failures, no well contaminations based off of those old wells that are still producing today. So I'll pass this out just so you guys see it. There's the second page, there's a little schematic that I laid out that kind of shows you the casing and the cement. And it kind of gives you a visual on how we do it that you can share one.
Yes.
With
Do
CSG.
local governments have
casing.
any say in this process?
That's that surface casing you talked about pounding in.
They can discuss their concerns with us if there's something that, you know, that is a concern up at the surface, but typically the state has final say on the drilling.
One thing I want to point out is that when we drill our initial surface holes and the 3 strings of casing that we set that help protect the aquifer, we use fresh water during that operation also. So, I mean, it's not potable water, but it's darn close to it. So we're not putting anything that's a contaminant into our drilling fluid while we're drilling through that aquifer. Now, we're not using salt water or anything like that. It is purely fresh water. I mean, for the upper third of the hole, we usually drill with fresh water. And we drill a water well for that, and then the minute we're done with it, we're plugging. So we use it just very little fresh water.
Yeah, so this is just a top view of what a typical casing would look like. It's a little difficult to see, but inside would be the tubing where the actual fluids from the formation would come up. It's typically a 2-inch line inside of the production casing.
It's just a 2-inch line inside of all that.
Yep.
Yeah.
Yeah.
With 3 big old casings in a line this big.
Yes. And they're all cemented into place. They're heavy-duty steel casing.
Steel cement, steel cement,
So you
steel
set
cement.
out 16 inches and then down to 11 inches and then down to 8 inches.
Yeah.
Yeah.
And then the 8 inches, I mean, I left it at 8 inches just mainly to show all the surface. And that 8 inches typically set down to, you know, in this area, let's say 12, 13, 1,400 feet.
Right.
So, I mean, at that point, we're typically about 1,000 feet below the aquifer at that point.
So is this drilling a for sure? Have you submitted paperwork to get permits and whatever?
Absolutely not. We aren't there yet. About 4 or 5 weeks ago, I presented at the city council to lease some of the city-owned property. We are leasing some of the city property. Our intent at this point is to drill outside of the city. And by the time we came under the city, we'd probably be at least 3,000 feet below the surface.
What is the estimated financial gain for the residents in the city, and how is that determined?
All landowners share in a royalty, and the royalty is typically 1/8 or 12.5% of all production from that particular well, and you share in it proportionate to the acreage that you contribute to that unit. Okay, so if you had 40 acres in an 80-acre unit, then you're gonna get 6 1/4 of that 12.5%. And so, yeah, the financial gains, obviously when you're dealing with small lots, is small. I mean, if I was gonna put a number to it,
And number 2 an acre.
let's just use a city home real quick, maybe an extra $200-300 a month.
Okay.
If you get, you get 10 acres or so, and now you're talking, probably, 2, 3, 4,000 a month.
Are your inspection reports, is that public information?
Yes, they can be FOIA.
Okay. I mean, do you guys have some kind of report that shows typical failures or any type of contamination you guys find during these inspections?
If a FOIA was put out for a specific well, we could have any of our field notes that are taken during any of our inspections.
Is there anyone that, like environmental news that follows that and maybe reports those things? From
Not that I'm aware of.
Not you.
No.
And John, just to address your question, a lot of their inspections and what they see, and when they come across the problem, it's typically I'm gonna say a fluid issue, something that happened above ground.
Gotcha.
Okay, whereas,
The diesel pump failure.
yeah, I mean, we use stuffing boxes around these pump units to keep, to keep the polish around, to keep the fluid in. Maybe a stuffing box is starting to leak a little bit. Now, we find that, we remediated it right away. And around these well bores, we have a cellar that's a corrugated metal, typically 6 feet wide. So, and with cement on the bottom of it. So anything that comes out of the wellhead would go down, would be stopped at that cement. It's all completely contained.
And you base that on, see, like, you had a picture where you guys see the 3 storage tanks. So that your containment area will contain all of that and some more,
plus.
say, rain or whatever.
Absolutely. The volumes of that containment area have to exceed the volumes of your storage capacity.
How did you do 14,000 inspections of 50-some people in a year?
That's busy.
That's over 200 inspections a person.
I think it's over 500 based on the number of field staff that we have. Our department isn't just people that go out and look at the wells. We have people that are technical specialists, groundwater specialists. We have permitting units, and then there's a section of that does go out and do inspections. And again, I think it's typically, if you just average it out based on the number of field area geologists to inspections, it's well over 500 inspections a year. Right now, for me, I'm right around 700 right now since January.
So how many do you do a day?
10 a week. Right?
I don't know the math right now, but there's days where I
You're
go
all
out
day
and,
looking at them.
yeah, there's days where I can go do 30, 40 wells. Other days, depending on what surface equipment's there, how they're spaced out, I may only get 5 or so done. But I'm there throughout the drilling process, day or night, because these rigs do run 24/7 once they get started, until they are drilled down to their bottom formation. So we come out, the area geologists come out during very specific portions of that drilling operation, where there's a higher likelihood that something could go wrong, or more complicated processes of that. We'd be out there any time of the day. I've been out there at 4 o'clock in the morning, been there for a few hours, and drove back an hour and a half back to my house. So.
What about the noise produced by these wells?
Most of them, if we're in a populated area, we electrify them, so they're quiet.
Yeah,
I mean, we go more electric anymore. Years ago, we used to do the old iron lug, yeah. And that's a thing of the past. I mean, electric is more efficient.
You may want to just talk about the drilling process. That's going to be your noisiest. It's, depending on whether they're doing a reentry or a full big well depth, they might be there a week or 3 weeks, drilling. So mainly it'll be, the drilling is just like the bit turning to the right. That just has like a constant hum. The motors are running. The big noise is sort of like when they're putting the casing together, the metal's clanking. So they'll put that together in, I don't know how many hours, Dan, for, obviously, if it's the shallower casing's not going to take very long, but the longer production casing might take all day to just put that casing together and it'll clang a bit.
It'd be-
It's
it'd be
gonna
doing that
sound
even
like
for a
maybe-
week or so. right?
Yeah, exactly.
It's
I mean-
a fairly constant from the rig.
Yeah, I mean, well over here is gonna take, depends on what rig, but the rig that we're using over here, does single derrick, it's probably gonna take 10 days to drill.
And then
Do you
through
have a
parts,
time frame on when you might be starting this, or that you're looking
Not at
at?
this, not at this point. You know, the hardest part with this is, what we did is we were testing a concept that we had. It's something we spotted over in St. Clair that nobody else has seen so far. So we tested it, we drilled a well up off the Masters Road here in May. We tested the concept, we proved ourselves right. We had identified a dozen of these type of reservoirs in St. Clair. We've leased all of them, except we knew there were what we thought maybe were 1 to 2 reservoirs under the city of Memphis. We stayed away from those initially until we tested the concept. And then, since we were right, we said, well, it's worth our effort to try to put it together. And whether we can or not, I have no idea. You know, working with a densely populated area is very difficult and very time-consuming and expensive on our part. So it's I'm going to say kind of a mountain we're going to try to climb, and hopefully we can get to the point where we can drill a well. Because there are some financial benefits for everybody, that would be involved in it, including the city. And but from a timing standpoint, I don't know. I mean, I've got another geologist with a different company. He's trying to do something over in St. Clair. He's been working on it for 3 years. So I just don't know. I mean, we'd like to think that if we can make everybody comfortable, because we understand the water supply is your biggest issue, and rightfully so. That's where your concern is, and that's where our concern is. I mean, the last thing we want to do is go in and jeopardize, our standing within the oil and gas industry, but also your situation with your source of water.
Okay, so what's the life expectancy on one of these casings?
I'm not.
I mean, the well's gonna be there forever after they plug it and stuff. But as far as for the life of the well,
Well, if we have steel pipes and concrete
Right.
going through the aquifer in 100 years, is it gonna start to deteriorate in 50 years?
we haven't seen that. I mean, like
We haven't seen it.
like we said, we haven't had 100 years. We're close to it. But 1927 is when we started permitting this.
So you have no idea how long it'll last?
Inside and concrete all
Well,
the way
concrete's inert
outside.
just like a formation. And what's gonna happen is, you have brine water that's throughout that formation, those formations up to your fresh water. Well, that's holding everything down just like it is currently. You have confining layers in there that's, holding the pressure down and things like that. So as far as it migrating to surface, I don't see it happening.
So you really can't inspect it once it's in there though, when it's sealed up?
It should last forever as far as, the casing and because there's no oxygen getting to that iron to deteriorate like you get it at surface. So it should just stay in place. I mean, I was in the orphan well program, and I plugged wells that were drilled like back in 1950s. I pulled it out. You could still read the writing on the casing. I mean, it was brand new casing. So that was, I did that in the early 2000s, mid 2000s, and so that was over 50 years, and the casing looked brand new. So
we can go into these wells and test the integrity of the casing. I mean, we can go in and put a packer in there and use some pressure to see if we're getting any leak off once we pressure up. So there are ways to test the mechanical integrity, but typically we don't do that. That's more done on a well that's more high pressure than these wells.
So we have a well site here that was drilled in the 90s, right off of Main Street. So is that inspected then? Is there a schedule to inspect these older casings and wells?
No, once they've been plugged and abandoned and restored, they're just they're not inspected unless something is brought to our attention.
Jason, quick question. Does the state of Michigan require the drillers to disclose every chemical they're putting down in the well?
I don't believe so.
Not unless they have a spill.
So only in the case of the spill would that be disclosed, is that correct?
Right.
And then who owns the,
I mean, we do submit a completion report to the DEQ, and in there, we do specify what type of fluid we did use for completion. So in most cases, you're gonna see hydrochloric acid, and it may be 2,000 gallons of hydrochloric acid, and so we do document what we have used.
okay, and then would I be correct in assuming, maybe I'm not, but who owns the, I would imagine this would fall under the RCRA cradle to grave law. Hopefully it does. If it does, who owns that responsibility?
The permittee, the person who got the permit.
And if that company goes bankrupt, who owns that?
That would then go to the orphan well program. It's run through the state of Michigan that sets funds aside to remediate, investigate and remediate any abandoned sites.
How many orphan wells are there in the state of Michigan?
Do you know the number?
It was low, but it just got some more on, so I don't know the exact number at this time.
I think there's,
Because it's a moving list,
yeah,
you know, as,
we're plugging them throughout the year, and then unfortunately some do get added throughout. In the 4 counties that I look over right now, there's 61 orphan wells, and 59 of those are from one operator. So that was a big
How
step.
many your territory?
I watch over St. Clair, Macomb, Monroe, and Wayne counties.
One thing I would like to state is that, Michigan Geosearch is the company who's coming in here to try to put this thing together. And Michigan Geosearch has been active in the state of Michigan since 1982, and they are in compliance and in good standing with the Michigan DEQ Oil and Gas Division.
So, how far out? I mean, I kind of have an idea where you're gonna put the well, and I know at city council you said as far south as Boardman, possibly. How far north, how far east, I mean, how big is this area?
How big is this? Well, the reservoir itself looks like it could be 300 to 400 acres in size. So if you can put that in perspective, 1 mile by a half mile.
Okay, and is your well gonna be, maybe you're gonna try to be central to that?
No,
It doesn't matter where in there?
Well, it does matter where we come in from, and we're gonna like to come into these reservoirs from the north.
In the north.
And the intent is, at least at this point, is that we do have a surface location outside of town that we would put our drilling rig pad on.
And now your surface location, that'll be at the northern part of the reservoir that you're trying to?
Yes, yeah, you could say that.
Saturday, for sure.
Any other questions? Okay, I have my contact information up here on the screen. If anything comes up, if you want to call or email. I also have cards if anyone would like those. You can get in direct contact with me.
Don't leave
I
it
can
first.
answer your questions. Anything else you'd like to?
Thanks for coming out.
How will you know if you're